This is a completely new lesson in physical science, and this is in preparation actually for chemistry class next year. So what we're going over the next couple of days is in preparation for chemistry class. It is still part of physical science, and there's several steps in being able to learn this lesson. So beginning from now, which is the first step, you really need to pay attention. Okay, so what we're learning about today is called molar mass. Molar mass. Before we begin, I need you to have several pieces of paper in front of you. First and foremost, I need you to have a periodic table, the one that says the modern periodic table of the elements in front of you. That was provided to you, a copy, actually multiple copies. You should have that out. It says the modern periodic table of the elements. This one has the average mass underneath each one of the abbreviations or the symbols for the elements. So I need you to locate it now before you continue. Once again, you have the periodic table of the elements in front of you. This is going to give you the average mass per element. So it actually has a key. If you notice right at the top, it'll have Hg for mercury, and it'll break down what each part of the little square for mercury stands for. If you're looking at that, you have the correct periodic table. I need you to use the exact one that I provided for you for this class, because every table has a different mass. We want to work with the same one so we don't have questions about our answers later on. So once again, you're using the periodic table that was provided for you in class. This is the one that has a key for mercury at the top. Once you've located that, I also need you to find the worksheets that say molar mass at the top. There's actually three different ones. Say molar mass at the top. Molar mass. There's three different ones. One has a chart, and then the other ones are simply just word problems with simple compounds and elements. So once again, I need you to find the worksheets with molar mass in order for you to understand this. Molar mass and your periodic table. So looking at molar mass, what it is simply defined is the total mass found in a specific compound, element, or substance divided by how much of the substance there is. We'll learn a little bit more later on about what molar mass actually is in a chemistry class, but this is important in order for us to learn about our gas laws, which is the next couple of worksheets that you'll see. So this is with molar mass. It's actually step number one in multiple steps in solving for my gas laws. Now, the most important thing that I need you to remember when it comes to this, when it comes to what molar mass actually is defined, is the units. You know that units are important in science. They're very important in our class, and therefore I need you to understand what the units are. You have grams per mole. That is always your unit for molar mass. I need you to remember that. Your unit for molar mass is always grams per mole. G over MOL, grams per mole. You need to write that down. You need to instill it in your head. You're always going to put grams per mole when it comes to your molar mass. Now, we know what grams is. Of course, it's a unit of mass. Mole is a scientific term. It's actually something that you use in comparison to carbon-12, which of course we know is an isotope of carbon, carbon-12, and it's based on something called Avogadro's number. And we'll learn about that later on. For now, just know that the unit is grams per mole, grams per mole. On one of the worksheets, it's going to ask you, is this the formula mass or is this the molecular mass of the particular compound? That's very easy. Once again, you're gonna ask in between both, is it formula or molecular? And simply put, formula is the easiest, simplest, most reduced form of the compound. Molecular mass is just how it's given. I've provided two examples of the same compound. This is known as glucose, which you probably know is another name for blood sugar. So you actually have sugar in your blood, and when it is measured, it is called glucose. Glucose is blood sugar, and these are both formulas for it. Now, this is my simplified version. My formula mass is just one carbon, two hydrogen, one oxygen. The actual formula for glucose, though, is C6H12O6. If you were to simplify it or reduce, if you know that term, you would know it is C1H2O1. It's the same thing, same compound. This is just the simplest form. It has been reduced, therefore it is known as your formula mass Your molecular mass is just how it's given, C6H12O6. That's just as a reference if you want to write that down. These are both examples. It'll help you with that worksheet. That's all there is to that. Once again, molar mass or units are grams per mole. Now, let me give you a couple of examples. This is actually very, very easy as long as you follow instructions, as long as you have the pieces of paper that I've asked you. Make sure you have your periodic table out. You're going to locate these on the periodic table. So let's look at my first compound. You have barium, you have nitrogen, you have oxygen, and then of course you have your compound combined. You're gonna look for every element separately. Remember when we balanced chemical equations, you were to separate every single one of these elements. You're gonna do the same thing with molar mass. So what you're going to do is you're going to separate every element and locate it on your periodic table. So we have Ba, which is barium. You're going to count how much of barium do I have? How many atoms? So as you can tell, there's only one of barium. So you're going to put barium and you're going to put a 1 next to it. Very simple. Then you're going to find barium on your periodic table. You find barium on your periodic table, it's going to give you a mass. It's going to give you a little number underneath the symbol. For this instance, barium, it is 137.33. That is its mass, its average mass. What you're trying to calculate is the total mass of the entire compound. Now, each one of the masses is per atom of the element. This is why you need to multiply it by how much you have. In this instance, because you only have one of barium, you're going to multiply 1 times 137.33. Very simply, when you multiply that, you're going to get the same number because it is multiplied by 1. Pretty simple. Let's go over to nitrogen. Now notice how there's a parentheses. This is simple math. You've worked with this before. You're going to multiply whatever is on the outside of the parentheses by everything that's on the inside. So in this instance, you actually have 2 of nitrogen. 2 of nitrogen. So you're going to place a 2 after the N for nitrogen, and you're going to multiply it by its mass. You locate nitrogen on your periodic table. You notice that the mass is 14.01. 14.01. Multiply 2 times that, you're going to get 28.02. 28.02. Then, lastly, you have O for oxygen. Whatever is on the inside of the parentheses gets multiplied by whatever is on the outside. In this instance, you have 6, 3 times 2 of oxygen. So you're going to place the 6 right there, multiply it by its mass. You're going to find oxygen on your periodic table. You realize that the mass is 16. 6 times 16 is going to give me 96. 96. Now I want you to make a note of this. If you use other periodic tables, sometimes they'll give you different masses. Sometimes they'll give you a more specific mass. Instead of giving you 14.01, it might give you 14.012345. That's going to give you a slightly different answer, and we don't want that. You're going to have too many questions about, what if my answer is this? What if my answer is that? This is why I'm asking you to use the same periodic table all across the class. That way we have the same answers. These are still the correct masses, they're just simplified to the second decimal place, and that's what I want. So once you have all 3, you're going to simply add them to have your total mass. So I'm going to add all of my barium, all of my nitrogen, all of my oxygen. Once I've added them, my answer will be 261.35. 261.35. Remember, your unit for molar mass is always grams per mole. Grams per mole. That's all there is to it. It's pretty simple. If you simply follow the steps, divide every single one of your elements separately. How much of each do I have? Each mass, multiply it. When I have my masses, you add them. Your total mass is in grams per mole. This is called your molar mass. Now, this is the first step in several steps we'll be taking in the next couple of lessons when it comes to our gas laws. But this is simple enough. There's a lot of practice on this. Let's give you a second example, the one here at the bottom. Once again, it looks like a lengthy compound. Don't let it intimidate you. It's very simple. You have aluminum. So once again, you're going to place aluminum underneath. You're going to separate it. How much of aluminum do I have? I have 2. I'm going to place the 2 right next to it. You're going to locate aluminum on your periodic table. Realize it is 26.98. Its mass is 26.98. You're going to multiply that by 2. 2 times its mass, you get 53.96. 53.96. That is the total mass for aluminum in this compound. Then we're going to work with SO4, which is a pretty common compound. This one, you have 3 of all of it. You're going to separate each one. You have sulfur and oxygen. Sulfur and oxygen. Let's work with sulfur. You have 1 on the inside, but you have 3 on the outside of the parentheses. So in total, you have 3 of sulfur. I'm going to place it right next to it. I'm going to multiply it by its mass. Once again, locate sulfur on your periodic table. Realize it is 32.07. That is a mass of sulfur, 32.07. We're going to multiply that by 3, which is how much of sulfur I have. Your answer is 96.21. 96.21. Then you have, lastly, oxygen once again. You have a lot of oxygen. You have 12. 12 atoms of it, 4 times the 3 on the outside. You're going to multiply your 12 by its mass. Once again, you locate oxygen on your periodic table. It's 16. 12 times 16 is going to give me 192. 192. Once you have all 3 of these, you locate it's only 3 elements. I have 3 masses. You're going to add all 3 of them. When you add all 3 of them, you realize your total mass is 342. 342.17. Once again, your unit is always grams per mole. G over MOL, grams per mole. 342.17 grams per mole. Once again, that's all there is to this. The only tricky part is your parentheses. Always distribute it, whatever is on the inside with what is on the outside. Pretty simple. This is my second example. Let me give you a third one and then we're done. This is an easy lesson. Let's look at this one. This is acetic acid. Sometimes you'll see certain compounds that are written differently and they look a little odd. For this instance, you'll see that the C's are separated, which is carbon. You'll notice that my hydrogen is separated and there's 2 random O's instead of being combined. You can rewrite this formula and it still is acetic acid. It's just sometimes, whether it's in a worksheet, whether it's in homework, on a quiz, in a book, you'll see that the formulas are written differently, but it's the same concept. So this is technically C2H4O2. You could have written it that way, but I wrote it out this way in order for you to understand that my rules do not change. It's still the same concept. I'm still going to separate my elements the same way I have always done. So in this instance, you only have carbon, hydrogen, and oxygen. So it's CH and O. CH and O. Once again, you're going to figure out and calculate how much of each do I have. C, I have 1 here and I have 1 here. This is why I wanted to give you this example. You combine both of them, you have a total of 2 when it comes to carbon. Locate its mass on its periodic table. You have 12.01. 2 times 12.01 is going to give me 24.02. 24.02. Then again with hydrogen, you have 3 and then you have 1 at the end. So you have a total of 4. 4 hydrogen times its mass, you're going to locate it on the periodic table. You'll see 1.01. 1.01. 4 times that is 4.04. That's the total mass for hydrogen, 4.04. Lastly, I'm going to work with my oxygen once again. I have 2 of them, 1 here, 1 here. So 2 times its mass, located on the periodic table. Oxygen is 16. 2 times 16 is going to give me 32. 32. Once I have all 3 of my masses, I'm going to add them. That's going to give me 60.06. 60.06. Once again, my unit is always grams per mole when it comes to molar mass. 60.06 grams per mole. These are 3 very simple, very easy, very easily understood examples of molar mass. Once again, let me remind you that you locate molar mass on your periodic table. There's nowhere else to find it. It has to be on your periodic table. It's the small number right underneath the symbol. Each one has, every element has its own mass, so therefore you have to make sure you find that. Once you found out each mass, you're going to multiply by how much of each I have when it comes to the elements. I'm going to add all of my masses. My final answer is in grams per mole. Now these 3 examples only have 3 elements. Some of them will have a lot more. Some of them may only have 2. The rules still apply. Just because it's lengthy or too short, we don't change anything about it. Please make sure you follow the same rules for every single one of these. This is for your molar mass worksheets. Now, one last thing is, this is the extended version, the harder or the longer route to take when it comes to this. This is to show you how we calculate them. If you feel comfortable in solving these without having to write it out exactly like this, I'm okay with it. I know your first worksheet, which is a chart, it asks you to do this. You have to do it. On your next ones, if you feel comfortable, you don't have to write it out like this. You can sometimes do it in your head, sometimes you can do it on a simple piece of paper, on scratch paper, add them, and then solve it on your own, as long as you give me the right answer in the right units and you've understood how you arrived there. I'm all for it. This is very simple math. I don't want to complicate it, but I showed you the longer version so you understood where all of this comes from. Once again, this is molar mass. My units are grams per mole. Formula mass is the simple version. Molecular mass is the exact version. Both are equal. You just reduce the formula mass. This is how you derive them. There are 3 worksheets for today and for tomorrow. I need you to make sure you finish those worksheets so you will understand how we do our ideal gas law and the